the class. All right. Can I share my screen? All right. Okay. So we're going to, these are the topics. That's the first session that we have. Okay, and you're gonna get used to everything that we're doing in here because it's pretty much the same, only the content is different. All right. So these are the topics that we're going to be covering today: the properties of numbers, the order of operation, the divisibility rules, rounding numbers and estimating, and some word problems. Most of the word problems that we're covering today are the ones that showed up in your test, the practice test that you did, the pre-assessment test that you just took. All right. Okay, so first we have to go over some terminologies, all right, for us to know what we're talking about. So addition is addition, okay, but because whenever you see these words in a test in a problem, all right, you need to know what that is, okay, because it could be something that you've not seen before, and it's not gonna get you the right answer if you just don't know the meaning. Anyway, so addition, when the addend plus addend is equal sum, most of us know this. Subtraction, no one does this, no one said minuend or subtrahend, but whenever you see difference, you know this is the result of a subtraction operation. Okay, multiplication, we have the multiplier and then the multiplier. Usually what we say is factors, and then product is the result of this. This is the term that we use for this. Division, we have the dividend is the big number. Divisor is what we divide the big number, the dividend, into. Okay, so if we're like saying 8 divided by 2, 8 is a dividend and divisor is 2, and the result is called quotient. All right. Okay, now the properties of numbers. We have several properties that we're going to discuss, and the commutative property, associative property, distributive, identity, inverse, and we're going to start with the commutative property. So commutative property is basically what it means, swapping. Okay, so if I do, for example, 2 plus 4 is 6, but if I do 4 plus 2 is also 6. Okay, so we can say that addition is commutative because it handle this. The numbers on which we operate can be swapped from their position without making any difference to the result.
Over in an hour, though.
Say that again. Oh, was it for me? Okay, okay. Okay, so over here for the 4 operation that we have, addition is commutative. A plus B is equal B plus A, and the example for that is 4 plus 2 is equal to 2 plus 4, which is 6. But we cannot say the same thing for subtraction, because if you go 4 minus 2 is equal to, but if you do 2 minus 4, you're going to get a minus 2. Of course, because I need to be technically correct in here, subtraction is commutative if you're going to move the number with its sign. Okay, because numbers are either positive or negative. So if I have here, that's a positive 4, and that's a negative 2. Okay, so if I want to swap using the negative 2 plus 4, I'm still going to get the negative 2. Okay, so, but nobody does this in this level. All right, so it's okay to say that. Okay, but subtraction is commutative if you keep the sign. That's a positive 4 and that's a negative 2. So if you swap them, you're going to get the same answer. Okay, multiplication is commutative at all level. 2 times 4 is equal to 4 times 2 is equal to 2 times 4 is equal 8. So that's done. Division is not, definitely, because 4 divided by 2 is 2, but if you swap, you do 2 divided by 4, you're going to get a half. Okay, so far what we know about commutative properties: when swapping, addition, multiplication are commutative, whereas subtraction and division are not. Okay, so that's another example. Okay, same thing that we just said. 3 plus 7 is equal to 7 plus 3, which is equal to 10. 10 minus 7 is 3. 7 minus 10 is negative 3. Okay, 3 times 5 is 5 times 3. So multiplication is commutative, and 10 divided by 5 is 2. 5 divided by 10 is half. Division is not commutative. All right. Now associative. Associative, let me just make it easy here. Okay, get the bars out of the way. I don't see that. All right. So associative. Associative is when you have 3 or more numbers or digits that you're operating on, the result is the same regardless of the grouping of numbers. So for example, if we have 4 plus 2 plus 3, okay, and you just don't want to go 4 plus 2 plus 3. I mean, that's pretty much basic, okay, but it might. Go ahead.
Hola. Hola. ¿Qué tú comes?
Jennifer, can you please mute yourself?
¿Ah?
Done? Okay. So if you have, for example, 4 plus 2 plus 3, and then you decide that you're going to associate the 4 plus 2, which means put them into brackets and do this operation first, okay? You're not going to change the result if you do that or if you do the other way. I mean, you can, because it's all positive numbers and it's all addition. So you can actually swap and you can actually put together without changing the result. So we say addition is associative. Subtraction, not the same, not the situation at all. Okay, so here is an example. 4 minus 2 minus 3. Okay, you go 4 minus 2 is 2, and then 2 minus 3 is -1. But if you do it the other way around, 4 minus 2 minus 3, you do what's in the bracket first, and this we're going to also talk about when we're doing the order of operation, which we hopefully cover today. 2 negative 3 is -1, then 4 negative -1 is 4 plus 1, which is 5. I want you to remember that. Oh, forget it now. We'll do that part later. Multiplication is not a problem when you have all of them together multiplied, all the digits or all the numbers are multiplied to each other. You can do whatever. 4 times 2 is 8, and then times 3 is 24. 4 times 2, 2 times 3 is 6. You multiply 4 by 6, it's 24 still. Division is not the situation at all. Okay, so just like the commutative property, addition and multiplication are associative, but subtraction and divisions are not. All right, another example of that. All right, so here is just self-explanatory. So 3 plus 7 is 10, and then plus 5 is 15. Here we're grouping 7 plus 5 is 12, and then we add the 3, that's 15. Same, we didn't change. 10 minus 5, 5, and then -2 is 3. Here we're going to do the opposite. We're grouping 5 minus 2. You get a 3. 10 minus 3 is 7. 3 is not a 7, so it's not. 3 times 5 is 15, times 2 is 30. Here we do 2 times 5 is 10, and then we multiply by 3, it's 30. Same. 20 divided by 2 is 10, and then you divide again by 2, it's 5. Here you divide 2 by 2, it's 2, it's 1. And then when you do 20 divided by 1 is 20. So you see, you don't get the same result when it's division or subtraction. So we know that subtraction and division are not associative. All right. All right. Now it gets interesting. Okay. So the identity property, I mean, you will never get a question about identity property in the test, direct question like this, that would be so easy. However, these are the things, these are the tools that you guys are using when you're doing your equation, when you're doing your math. These are the tools that help you solve problems. Okay. So identity property is what is the number that when you add to a different number, you're not going to change the identity of this number or the value of this number in math words. Okay, it's a 0. You add 0 to anything, nothing's going to happen. You get the same thing. All right, and it's the same thing with subtraction. If you got an amount of a number, and you subtract 0 from that number, nothing is going to change. It's still going to be the same number. So it keeps the 0 does not change the number when you add it or subtract it. However, when you talk about multiplication and division, it's not the 0, because if you multiply anything to 0, you're just nulling the whole thing. You're xing, you're annulating the whole stuff. Okay, but the digit that you use to keep the identity of number when you multiply it is the 1. Multiply 100 by 1 is going to be 100. 1,000 by 1 is still going to be 1,000. Okay, and the division also, same thing. You divide by 1, nothing is changing. All right, so the additive and subtractive identity is 0, and the multiplicative identity is 1. All right, that's the inverse, the identity property. I'm sorry, not the inverse. identity property. That, when we say identity property, you do not want to change the value of the digit, okay? And I'm going to refer to this slide when we're talking about steps and solving an mathematical or algebraic equation. Inverse property, on the other hand, you want to actually get rid of that number. You don't want it here. So what are you going to do? Okay, so for addition, okay, you're going to use the opposite number, which is the inverse of addition, all right? The opposite number. So if I have 4 and I want to get rid of that 4, I'm going to add a -4 to that 4. So 4 plus -4 is going to give me a 0. And I got rid of that number, all right? And here, for example, 3 plus -3 is 0. Okay. And this we're using again when we're solving equations. All right. So the inverse of an addition or subtraction is simply the opposite number, the same number with the different sign. So if it's a negative, the opposite is going to be a positive. And if it's a positive, the opposite is going to be negative. When we talk about multiplication and division, the inverse is going to be actually the inverse. So if you have 3 and you multiply it by 1/3, or as a matter of fact, you'll be dividing it by 3. Okay, you get a 1. And if you have 1/3 and you multiply it by 3, you get a 1. So the inverse here is 1 divided by the number. Okay, that's the inverse of any number. Or if it's the number, if it's in a fraction form, then it is the denominator. Okay, next time we're going to speak about fractions and denominator and decimal numbers. So if you don't get this, that's all right now. All right. Okay, but just if you're at any time confused, you want to get rid of the 3, you divide it by 3. You have a third and you want to get rid of the third, you multiply it by 3, because 3/3 is a 1. Okay, let's I can give you another easy. So like half. Okay, if you multiply half by 2, you're going to get rid of the half and get a 1, because 2 halves is 1. All right, any questions so far? Okay, distributive property, this they like very much in this in the CST test, and they ask you, well, you might get a problem that is in fact a distributive property. Okay, so in here, if you have a bracket, so let's say let me use the example first, and then we go to the algebraic form. I have 540 multiplied by 3. Now, usually we do mental math when we're multiplying big numbers, okay? But how are you going to do this? Are you going to say 3 times 0 is 0, and then 3 times 4 is 12, 2, and I have 1, and then 3 times 5 is 15, and 1 is 6. It's crazy, right? You can break the 540 into 500 plus 40, okay? And then you can say 3 times 500 is 1500, and 3 times 40 is 120, and now it gets easy, okay? 1500 plus 1 plus 120 is 160. So when you're doing this in your mind, because I am sure that we've all gone through these little mathematical problems in our mind, but we don't know the name of it. This is called distributive property. Okay, you're applying that when you multiply into a bracket, okay, you can add what's in the bracket and then multiply it to a, or you can actually multiply what's in the bracket by the multiplier at the beginning and then add the sum. So a times b plus c is equal to a times b plus a times c. Okay, and it's also the same thing with subtraction. All right, so here, for example, that is 3 times 765. Okay, so we're going to expand the 765. We're going to make it 700 plus 60 plus 5, and then we're going to multiply 3 times 700 plus 60 plus 5. Don't forget to put the brackets here. So 3 times 700 plus 3 times 60 plus 3 times 5. Now 3 times 700 is 2100. 3 times 60 is 180. 3 times 5 is 15. Add them together and your answer is going to be 2295. Okay, now I want you to remember that it's always what's in here is either a plus or minus, and the multiplication is in here. So multiply inside the bracket. It's not the other way around. It's not a plus 2 times 9. That is totally different, okay? Multiply the sum in the brackets, all right? Okay, this is just a summary, okay? The property, the description, and the example. So we talked about the commutative for addition, multiplication, and associative for addition and multiplication, distributive property, the identity and the inverse, and the zero product for multiplication. Anything you multiply by 0 is going to give you a 0. Okay? Okay, now let's get an example. Okay, I want you to, I'm gonna let me see if I can pull in here. I'm gonna give you a poll so we get used to that. Okay, so now everybody, you should have a box with the pawn and choose whichever answer you think is the right answer for this. Okay, I'll give you like 10 seconds and then I'm gonna end the poll because I got almost. Yeah, perfect. Oh, I'm so happy with the amount of participation. Good. Okay, so I'm going to share now the result, and the correct answer is the distributive property. So most of you, as you can see, got it right. Let's see. Okay, what do we have in here? Okay, so we have a box that contains a box, a big box. I'm gonna draw it. Okay, a big box. Okay, it contains 7 green marbles, 7G, and okay, and then 2 yellow. And I have 5 boxes of this in this package. Okay, and I have of this 1, 2, 3, 5. Okay, so if I want to know how many of each color do I have, what am I doing? Okay, I'm simply going to say 5 times 7. Okay, because I have 5 boxes. Okay, and I'm gonna have also 5 times 2. So what am I using? Am I using commutative property? Am I swapping here 2 and 7 or the 5? Or am I grouping? Or am I distributing using the distributive property? So that's what I'm doing. I have here, I can even write it into, I'm gonna show you how we do it like this way algebraically. So I have 5, oh sorry, not 5, okay. I have 7G, 7 green, plus 2 yellow, and I'm multiplying everything by 5. That is the distributive property, okay? So it's 5 times 7G plus 5 times 2. All right, so you see now, those of you who chose commutative and associative. All right. Any question here? Moving on. Okay. All right, another one. Okay, so here just an extra practice. I don't want you to solve it, okay? Because that's actually very easy to solve it. I mean, you have a calculator in your test. So you can use the calculator even on your phone. You can use it with your phone, all right? But that is the question they want to know. When you use the distributive property to rewrite the expression, what's it going to be? I'll give you another 15 seconds to make one whole minute, and then we're going to end the phone. All right, and I'm ending it. Oh yeah, most of you got it right. 16 out of 23 who answered got it right. All right, so yes, this is what it's going to look like, okay? You're going to do 15 times 18 plus 15 times 17. And you see, I mean, A and B are totally irrelevant, okay? But you can get confused between C and D, and that's why I told you, remember what we're doing, all right? It's two products you add together. Okay, so yeah, it is. All right, I think that one was out of the another one. Testing the same concept again. What's going on here? Which one is a distributive property? All right, most of you got it right now. All of those who answered got it right. Good. Okay. Keep trying, my friends. Think about it. Which one is the distributive property? What is A and what is B? What is C? What is D? All right, I'll end the phone now. Okay, and I'm sharing. And again, most of you got it right. It is D. Okay, so over here, this we have in A and B. This is the commutative property we're swapping. Here we have the rose and the tulip, and then we swapped. And here we swapped the cactus and the rose. Here, what is going on here? I don't understand. This totally something that doesn't make any sense. But D is a distributive property, okay? You're multiplying the cactus with the rose, and then you're adding the cactus and the tulip. So, I mean, I go like this, all right? To make it just for you to remember what it looks like. All right, now let's do the order of operation. Okay. Now, if you don't follow, I mean, numbers are, because we talked about the properties of numbers, so they kind of, if you have a long mathematical sentence, okay, and you go about it in different ways, you might get a different answer. So that's why all the mathematicians came up together and decided, well, my friends, we have to find an order of operation. In that way, we keep the result the same. We keep consistent with how we solve the problem. And that's the thing for it. That's what we use. Please excuse my dear Aunt Sally. Okay, so remember this sentence, and the P goes for parentheses. E is exponent, multiplication, and division, whichever comes first from left, addition, and subtraction. So whenever you have a mathematical sentence, okay, and you want to find out the answer for that, you want to solve it, okay, you have to follow that order. All right. And if, I mean, you keep practice, you don't need this anymore. Please excuse my dear Ansal. All right. But anyway, it's there. Okay. Okay. So for example, which expression is equivalent to 32? And I'm going to write it here for you. Okay. Please excuse my dear Aunt Sally. And then I'm going to put the poem. Okay. So just try yourself first. That would mean that you do it. And I want you to do not use a calculator now. I mean, even if you use the calculator and you don't do the right, you don't follow the same order, the correct order, you might get a different answer. Ten more seconds. If I'm closing the post so fast, please let me know you need extra time. I'm all right with that. I mean, right now I give another 10 because I see a lot of some answers as that keep coming. All right, I'm gonna end it now. And we're sharing the result, and the correct answer is C. And I'm so happy. I mean, almost everybody got it right, but 2 people got B. Okay, so now let's do this together. All right, so this is, we have to do every one of them, right? And find out which one is equivalent to 32. That's the question. So here I have 30 plus 6 divided by 3, negative 2. So all the operation that I have here is addition, division, and subtraction. Okay, so I'm going to do the division first, right? I don't have any multiplication. So I'm going to keep the 30 and the 2, and I'm going to divide 6 divided by 3. We keep the 30 plus 2, negative 2. Now, you still have 2 more. Okay, so you're going to go from left to right as well. So 30 plus 2 is 32. Almost right, but you have a negative 2 here, so it's 30. That's not right. Now we go to B. B, I have multiplication, I have addition, and I have division. Okay, so I would add some parentheses here to make it easy for myself. All right, so here, 9 times 3 is 27, and 8 divided 2 is 4. So 27 plus 4 is 31, still not the same one. Here I have the parentheses made up for me, so I'm going to just solve what's inside first. Okay, that's what we do first. So inside I have only one addition. If inside the parentheses you have more, then you have to apply the same order of operation inside the parentheses as well. Okay, I mean, for example, if you have here 9 square, okay, you're going to have to solve the 9 square first and then add it to 7. All right, so 9 plus 7 is 16, and 2 times 16 is 32. That's your correct answer. For the sake of the solving, because we're learning, all right, we're going to do D as well. What do I have here? I have an addition and I have multiplication, subtraction, and division. Again, I'm going to do the multiplication or and division first, but whichever comes from left first. So I have the multiplication here. So 2 times 4, that's it's an 8. Okay. And then 10 divided by 2, that is a 5. Okay. So now it is 6 plus 8 minus 5. Am I going to do 8 minus 5 first or 6 plus 8? 6 plus 8 because that's the order. I have to go from left to right. All right. And it gets a little bit complicated. And before we go into this, I just want to tell you what is exponent in case you forgot. So for example, if I have 3 raised to the power of 2, it means that I'm going to multiply 3 by 3 by itself. That amount of time, that number of time. So here it's twice, so 3 times 3 is going to be 9. Okay, but if I have 3, 4, that's mean I'm going to go 3 times 3. How many times? 4 times. Okay, that's the base, and that is the power. Okay, so you multiply the base by itself, the number of times as it says in the power, right? And I'm going to put the formula. I'm giving a little bit of extra time here because I know it takes some time. I have 41% of you participated, so I'll give it another 20 seconds, see if you're still solving it. All right, I'm still getting answers. Great. And most of you got it right. Mm-hmm. Mm-hmm. Another 10 seconds, and then I'm going to end. All right. And your correct answer is A. Okay, so some of you were confused. Wow. Only 24 answered, and half of that, half of you got it right of the 24. But anyway, let's just go ahead. Okay, so
Professor, I'm sorry.
go
When
ahead.
you explain this, can you go slow, please?
Yeah, sure. Okay. Okay. So we're gonna write here parentheses, please excuse my dear Ansar. All right. So the first thing we have, I have a parentheses. Okay. So I'm going to go what's in between, what's inside that bracket first. Okay. And inside that bracket, I have an exponent. You notice here, I'm not taking the extra, the outer exponent of the bracket. I have 2 exponents here. I have 2 powers. So I'm going to use what's inside first. Okay. So I have 6 minus 2 squared. I'm going to follow the same order again inside the bracket. So I have, this one is going to go first, the 2 squared, because it's an exponent, right? All right. 2 squared, it's 2 times 2, which is 4. So here I have 6 minus 4. Now I'm going to do the subtraction. It's a 2. So now I'm going to rewrite my sentence again, my mathematical sentence again. But I'm not going to use the bracket. I'm just going to use 2, but I'm not going to forget the exponent in here. All right? So here you go. Same thing. Didn't change anything. Only put the 2 that I came up from here, and I kept that exponent. You see where the second exponent coming from? Because you have 2. Inside, you have 2 to the power of 2, and then the whole bracket is raised to the power of 2. All right? Now again, we're going to go into the second one we're going to use is exponent, because I have exponent. Look what I have. I have multiplication, I have addition, I have division, I have exponent, and I have subtraction. So I'm going to do the exponent again. Again, 2 to the power of 2 is 2 times 2, which is 4. All right, I'm going to, because, hold on, let me, because it's, I put everything and then we're going to go. Because it doesn't, I mean, I have to click something is not going. Anyway, so I'm rewriting everything. Okay, but now I'm going to get rid of the 2 to the power of 2 and put its value, which is 4. Now I'm looking again. I have a multiplication, I have an addition, a division, and a negative subtraction. So I will go to the multiplication and division, whichever comes first. So the first one I meet is the 3 times 6. I'm going to cross the 3 times 6 and put their value, that is an 18. Okay, addition, I'll keep addition as is, not changing that. And then I'm going to the 20 divided by 4, that is a 5. Okay, so now it's 18 plus 5, negative 1. Okay, I'm using here brackets because it's all right to do this to make it easier for yourself. Okay, if I have here multiplication and I have division. All right, so I'm going to do the multiplication first and then the division, only because the multiplication comes first. So it's all right if I put the brackets in here and then go ahead and solve what's inside the brackets and then see what's going to happen. Now I have 18 plus 5, negative 1. So the addition comes first. I will add 18 plus 5. That is 23. And then negative 1 is going to give me a 22. All right. You got it now?
Yes, thank you.
Yes.
All right. Okay, perfect. All right, moving on. A new concept, divisibility rules. Okay. So a number is divisible by another number if when you divide, you use a divisor to divide the dividend, you come up with a whole number, which means you do not have remaining. No remainders. All right. So there are like numbers are kind of tricky. Okay. And they kind of have those, like those little shortcuts in between them. So for example, let's look at the, I mean, you know that any number that ends with 0 is divisible by 5 and by 10 and by 2 actually, right? You know that. If I give you that number right here, for example, I give you 350, you know that you can divide this by 10, okay? And you get 35. That's a whole number. You don't get 35.5, okay? You divide that number by 5 as well, and you're going to get a 70, okay? You can still divide that number by 2 as well, and you're going to get 150 and 25, 175, okay? So these are what we call divisibility rules. And I am sure that we're all of us, we do these things when we're using regular day-to-day math, because we're using regular day-to-day math, even if we do not recognize it. But that's what we're doing. All right. Now, some numbers are clear and some numbers are kind of tricky a little bit. So let's go one by one. Let's do the one that we know first, okay? Okay. So any number that ends in an even number, and 0 is an even number, okay, is divisible by 2, correct? 3,978, all these are odd, but the 8 is even, okay, and I know that these numbers are divisible by 2. This number, this whole number is divisible by 2, but whereas I know that this number is not going to be divisible by 2, it's going to give me a half at the end, okay, not a whole number. I will have some remainder here that I'm going to have to put a decimal point and add a 0 to finish my division, okay? So that is the 2. All right, let's go to the 5. The 5, it has to end with 0 or 5. Anything else is not going to be divisible by 5. It has to be a 0 or 5. Now we go to the 10. The last digit must be 0 for the number to be divisible by 10. Any other number is not going to be divisible. Any other digit at the end other than 0 is not going to be divisible by 10. So we already know the 2, and we already know the 5, and we already know the 10. Now the 3 is kind of cool, okay? Because a number like this, for example, 139, I would think automatically that this number is divisible by 3 because look, it has 3 here and it has 9 in here, okay? And these are all on table 9, okay? So it's definitely divisible by 3. But the reality is not, okay? Because if you want to know before dividing, before taking your calculator and doing the division, if this number is going to yield a whole number or a fraction or a decimal number or a part and a whole and a part, okay? All you have to do is add the digits. Okay, so if I go ahead and add 3 plus 1 is 4, plus 5, that is a 9. If the sum of the digits of that number are divisible by 3, then this number is divisible by 3. So I'm adding here 3 plus 1, that's a 4, plus 5 is a 9. Yes, 9 is divisible by 3. But when I come in here, 1 plus 3, that is a 4, plus 9. Okay, that is not divisible by 3. 1 plus 9 is 10. That's a 13. 13 is not divisible by 3. Okay, 13 is not divisible by anything actually except 13. Okay, so that number is not divisible by 3. So the rule for the 3 is that add the digits, and if it's divisible by 3, if it is divisible by 3, then the whole number is divisible by 3. I'll jump a little bit and go to the 9 because it's the same rule, but this time it's going to be divisible by 9. So here I have 7 and 1, 1. 7 plus 1 is 8, plus 1 is 9, that is a 9. 9 divided by 9 is 1. Okay, here I have a 9 and I have a 3. 9 plus 3 is 12. 12 is not divisible by 9, so it's not. Okay, now the 4, we're not looking at the last number, we're looking at the 2 last digit. If they are divisible by 4, then this number is divisible by 4. Okay, so now we learned the 2, we learned the 5, and we learned the 10 because we know them already. We learned the 3, and we learned the 9, and we learned the 4. The 4 is the last 2 digits. Are they divisible by 4 or not? Okay, 12. Is it divisible by 4? But you're not looking at 1 alone and 2 alone. I mean, you're looking at the 2 last digit as an entity, 12. Okay, or 24, or 75, whatever that number ends. Okay, 78 here 15, here 12, 75, 48 is, okay, 11, 90. So you're looking at the last 2 digits. Okay, now the tricky one is the 6. 6, you can factorize into 2 times 3. Okay, so you know that 6 is divisible by 2 because it's an even number, and you know that 6 is divisible by 3 because 2 times 3 is 6. Okay, so for any number to be divisible by 6, it has to be divisible by 2, which means it has to be even. Okay, and it also have to be divisible by 3. 2, not one condition, 2 conditions for the 6. The number is even and the number is divisible by 3. All right, so be careful about this. 6, it has to be even, which is divisible by 2, and it has to be divisible by 3. So you add the digit. 4 plus 8, that is 12. 12 divided by 3 is 4, so yes. That number 20 is not, even though it's even, but 2 plus 0 is 2, which is not on table 3. It's not divisible by 3. Okay? Cool? All
Yeah,
right.
so this we just have to memorize, right? Like the ones we
Yeah, by practice, you don't need to memorize if you practice it a lot. Okay, because you actually, I mean, we already know the 2 and the 5 and 10, and you added the 3 and the 9, which are pretty much the basic the same. So you're actually what you're going to memorize is the 4, the last 2 digit, and the 6, which is 2 and 3 together. Yeah, you do have to remember it. All right. Okay. So here's the question. I'm gonna put the poll. This one is just for practice. It did not show up in the test. And I put down here the schedule because I know you still might be a little bit confused. Which number is divisible by 9? All right, I'm gonna give you another 10 seconds and we're gonna end the poll. Okay. Okay, most of you got it right. It is 2 plus 7 is the 1. D is the correct answer. Let's go ahead. So which number is divisible by 9? So 9, I'm going to add the number and see if they are divisible by 9. All right, so 2 plus 1 is 3. 3 divisible by 9, divided by 9 is going to give me a fraction. That's not it. 2 plus 3 is 5, same. 2 plus 5 is 7, same. 2 plus 7 is 9. 9 divided by 9 is 1. Okay, so D is the right answer. All right. Okay, now this one showed on the practice test. I think they might have removed it, but it was on one of the practice tests I took. Okay, to prepare this. This is, I'm going to talk a little bit about it to make it easy for you. Okay, so I have a number here, 1A372, that has a factor of 6, which means that this number, if I divide it by 6, I'm going to get a whole number, which means that it's divisible by 2, and it is, and it's also divisible by 3. Okay, now they say, the question is, if A represents the digit in the thousand place, that is the thousand place. Okay, and it's one digit. It's either 0 or 1, 2, 3, 4, 5, 6, 7, 8, or 9. It cannot be 10. It cannot be 11. It's one digit. Okay, A is one digit. Then, what is the sum of all possible value of A? All right. So here they want you to find out a value of A. Let's do one first. One value of A that makes this number divisible by 6 because it has a factor of 6. Okay? And then find another one, and then another one, and another one, and then add them together. All the possible values of A. All right? I'm going to put the poll now. This one.
Can I ask a question, please?
Yeah, sure.
Or would you want me to wait till after the answers?
Are you going to give away the answer?
Oh no, let me wait till after we answer. 'Cause
Okay.
I wanna see if I could just use an educated guess without, but I'll wait till after.
All right, perfect.
Okay.
I'd love to hear that. I'm going to give it another 15 seconds. because I know this one requires some work. And I'm gonna end it now. All right. I'm sharing the result. The correct answer is C, 15. And I would like to know why most of you got 18. I'd like to hear from you in here. All right, but let's solve it first. Let's do it together. Okay, so like I said, okay, the number has a factor of 6, which means the number is divisible by 6. Okay, A could be any digit between 0 to 9. All right, so which digits? Not 1, all the digits between 0 to 9 that will make the number divisible by 6. So we're going to work in an opposite way, in the reverse, okay? The rule for divisibility of 6 is that the number has to be even or end by 2, I mean even, and you add the digit and they're going to be what? Divisible by 3. All right, so we have two conditions here. The number has to be even and it is even, so we have this given. Okay, we're lucky, we have this given. So now we want to test for the 3. Okay, so what I did is that I started adding the digit like we do, okay? So I have 1 plus A plus 3 plus 7 plus 2. Now I added 1 plus 3, 3 plus 7 is 10, plus 2 is 12, plus 1 is 13. 13 is not divisible by 3, right? 13, if I divide 13 by 3, I'm not going to get a whole number. I'm going to get a fraction. So 0 could not be it, okay? Because when I just look at 13, it means that A is 0. What if A is 1, okay? And now I started to make my trial and error, okay? So I made a little schedule here, okay? And here, I'll move the boxes first. I went with A is equal to 0, so 13 plus 0, 13 does not work. What if 1? I'll try 1. So 13 plus 1, what if A equal 1? 13 plus 1 is 14, still not working. Now 2 is working because 13 plus 2 is 15 and 15 divided by 3 is 5. So 2 is a possible value for A to make that big number divisible by 6. Keep going. 3 and 4 is not working. 5 is going to work because 13 plus 5 is 18 and 18 divided by 3 is 6. So yeah, it does work. 6 is not working. 13 plus 6 is 19. 19 divided by 3 is not divisible. 13 plus 7 is 20, not working. 8 is going to work as well because 13 plus 8 is 21 and 21 divided by 3 is 7. 9 will give me a 22, so it's not going to work. Now, my possible values of A are the 2 and the 5 and the 8. These are the only 3 digits that are going to make the number I have, the 18372, divisible by 6. Now, the question is, I need to add them because the problem requests the sum of all possible digits. So 2 plus 5 plus 8 is 15, and my answer is 15. Do you guys want me to go over it again? Do you have questions?
I don't
Yeah.
know what just happened.
All right. It's I mean, like I told you, this is a nasty one.
Yeah.
Okay.
So
It's a
let me
Go
tell
ahead.
you what my thinking was, right? And I got it
Okay.
wrong. But when you said A has to be a number less than 10, right?
Mm-hmm. Mm-hmm.
I picked 7. I don't know why. That was just my thinking.
Yeah, because
then
7
after
is
you showed the answer, I said, okay, if it's a factor of 6, then it has to be like an even number, and 7 and 13 and 15 is not even. So then I was thinking 18. Just kind of giving you my line of thinking, right?
yeah.
So
All
can you
right.
please go over it again?
Yeah,
Because I'm so
I'll go
lost.
over it again. I'll go over it again. But do I have any other questions? Anybody wants to share?
Yes, so I got the answer correct, but I did something completely different. And I
What
don't know
did
if it was just guessing or what. But I used the answers to just add. So that's how I selected 15 by doing 5 plus 1 is 6. And 6 is divisible by 6 as well as the 3 and the 2. And I got 15. But I don't know.
what did you do again? How did you use
So
the
I
answer?
used the different answers to check. So I end up got to
Oh.
see that if 5 plus 1 is 6, which 6 is divisible by 6 as well as 2 and 3. So that's how I settled with C.
Oh, that's interesting.
I know, I don't know, because I didn't know all that working out that he just did. Then that's how I figured it out.
Okay, I mean, come on. I really do believe that this one is really nasty. But let's be honest, they throw one or two nasty ones in the middle of each test. Okay,
Right.
just to
Yeah.
make people study more. All right. So our bet in this class is that we do not lose the easy ones. All right. Okay.
Right.
But this one requires more than 2 minutes. Okay. It took me some time to get it. Okay. So let me do it again.
I'm
So
sorry, can I say
yeah,
something?
go ahead. Yeah, sure. I'm sorry.
I did something else, so now I realize that wasn't correct, but for some reason I got to the result, to the same result. So I add all the digits that you have except the A, of course, and I got 13. And then I try these numbers 7, 13, 15, 18 to add to the 13 that I got for the rest of the digits on the number. And the
Okay.
only one that was divisible by 3 was 15. If
Okay.
that makes sense.
It does make sense in a way.
So instead
All
of
right.
A, I put 15, and that
Okay.
is working for the to be divisible by 3. That's the
Okay.
only answer correct besides.
Okay. Yeah. It does make sense. It does make a lot of sense, by the way. Okay. Because if we go back, let me go back. I'm just going to answer this and then I'm going to go back again. Okay. And do it. Okay. Because, all right. If you see there's a pattern here, okay. 2 plus 3 is 5, plus 3 is 8. Okay. However, but still, you had the 7. 2 plus 5 is 7. You had the 7, but it didn't work, right? So it was kind of lucky. No, it was lucky. Okay, because, okay, hold on. Let me go back. Because you have the 7. One of the option was the 7 and 2 plus 5. Okay, because the same concept you did is that you did 2 plus 5 plus 8 is 15 and you added the 15. But when you added the 7, it didn't work fine.
Oh, yes, because I'm sorry,
Okay.
because the
Yeah.
13 plus 7 is 20, which is not divisible by 3.
Yes.
So it
Yes.
wasn't working. It's only 15 that is working.
Okay. So so that would be guessing. All right. It's a guess. And sometimes we do. You have to guess because
Okay.
you don't leave anything empty. You have to answer all the questions. Okay, in this test. So don't worry about that. All right. So let's do it one more time. Unless anybody else want to share?
Professor,
Yeah, go ahead.
I just used the 7 instead of A, then use the 13 instead of A, and the 15 instead of A, 18 instead of A, then divide 6. So I got the right number is 15.
15.
Yeah,
Yes. Yeah. But
just
yes, the same thing. It's a guess, okay? But it did work for you guys, which is good. Okay. However, let me
B is the whole number.
yes,
So I use
but let me remind you of that part, okay? Then what is the sum of all possible value of A? These are not one possible value of A. These are the sum of all possible value of A. So the 7 could be 2 plus 3 plus 4, okay? Or the 13. So we're looking for possible values of A, not to replace, okay? You want to change that A, okay, into 1 digit. You want to substitute that A by 1 digit to make it divisible by 6. Or in our situation, because already we have the 2. We have the 2 to make it divisible by 3. Okay. So you guys use it does happen sometimes, okay, that you guess and it turns out. I mean, like, I don't have the statistic for it, but I'm sure there is a statistic of guessing. Okay, because I mean, People do this.
I'm sorry, I feel like we just did the backwards problem, so we started from the back going to solve the
Yes.
problem.
Yeah,
It
yeah.
was
But
working.
yes, but yeah, exactly. But this is why it's tricky, okay? Because they did not give you the possible values of A. They give you the sum of the possible values. You know, if they gave you the product, okay, it would have been much easier, okay? But they didn't, because you can actually factorize the number and try. But the sum, you have so many options here for the sum. This could be 1 plus 6, or it could be 2 plus 5, or it could be 3 plus 4. I mean, only the 7, but go with the 13. It's 1 plus 12, 2 plus 11, and keep going, all right? But then it's not going to be, well, yeah. If you would break the number into 4, if you would break this one into, I mean, what are the possible sum? I'm just thinking aloud, but I don't want to waste your time. So the A has to be 1 digit. So 7, you can try for 1, you can try for 6, you can try for 2, you can try for 5, you can try for 3, okay, and you can try for 1, 6, 2, 5, 3, and 4, 4 and 3, and you go back, okay? And we found already that the 2 would work, okay, and the 5 would work, okay, but the 3 and 4 and 1 and 6 are not going to work, okay. For the 13, you could try for 4 and 9, or 5. I mean, no, it's very difficult to do it that way. What I'm doing is just, it's actually what I'm trying to do right now with you guys. It's actually impossible. It's going to take forever. We need like a log calculator for this one. So anyway, let's do it the correct way of guessing. Okay, one more time so you understand what's going on. Okay, so we have a number that has a factor of 6. So we got this part. Everybody got this part. When a number has a factor of 6, it means this number can be factorized into 6 times a number equal to 1A372, which means that if I divide the 1A372, I'm going to get by 6, I'm going to get that number, which is a whole number, okay, because it's a factors, all right? So factors are whole numbers, all right? Okay, so the number has a factor of 6, which means the number is divisible by 6. Now, we have to understand that A represent 1 digit. So it could be 0, it could be 0, or 1, or 2, or 3, or 4, or 5, or 6, or 7, or 8, or 9. That's it. Okay, because each digit, they would never give you A in a question like this that represent 12 or 13. It has to be 1 digit. Okay, so now, okay, the number has to be divisible by 6, which means it has to be even, and the sum of these digits has to be divisible by 3. So what we're going to do is that we're going to add the numbers, all right? Like we all got it up till here. 1 plus A plus 3 plus 7 plus 2 is equal 13 plus A, correct? Everybody got it up till here. Now,
Yeah.
what we're going to do is that we're going to try to substitute for A by the different digits and check if any digit would give me a number that is divisible. I'm going crazy with it. Okay, and to see if any one of those number is going to give me a number that is divisible by 3. All right, so that's what we're going to do now. We're going to substitute A. Okay, here, that's the schedule here, the table here that I have. We're going to substitute for A. If A is 0, then 13 plus 0 is 13. 13 is not divisible by 3, so that's not it. So A could not be it. Now I'm going to try the 1, okay? 13 plus 1 is 14. 14 is not divisible by 3, okay? Now I'm going to put the 2, okay? 13 plus 2 is 15. Now 15 is divisible by 3. So my number could be 1, 2, 3, 7, 2. This number is divisible by 6. If you go ahead right now and divide it by 6, you're going to get a whole number. So the 2 works, correct? It's an option. 2 is an option, but I still have other numbers to try. So I'm going to try the 3. So 13 plus 3 is 16. 16 is not divisible by 3. 4. I try with 4. Okay. 13 plus 4 is 17. Not divisible by 3. So 4 is not working. Now I'm going to try the 5. Okay. The 5 will give me 13 plus 5, 18. 18 divided by 3 is 6. So it does work. So my number could be 1, 5, 3, 7, 2. And if I divide it by 6, I'm going to get a whole number right away. Okay. Now I keep trying. With the 7, I get a 20. 20 is not. 8 will give me a 21. 21 divided by 3 is 7. So it does work. So my number could be 1, 8, 3, 7, 2. And if I divide it by 6, I'm going to get a whole number. Okay. I'll go back to the last part of the question, which says what? It says, what is the sum of all the numbers, all possible value of A? These are the possible value of A. The 2 and the 5 and 8. I'm going to add them, and this is how I'm going to get to my 15. You see how mean it is, this question?
Yeah, but I got it now.
Nasty, nasty. It's a nasty one. Totally agree, my friend. I mean, I couldn't believe myself. I mean, why would a teacher of childhood must do this? Okay, or early childhood for this one. All right.
Hold up.
Anyways, yes.
Question. Hi.
Go ahead.
So yeah, will there be other questions like this in the exam? And also, would you be working with more problems like this so we can actually I can actually get more?
Yes.
You know.
Yes.
All right.
Yes.
Practical. Thank you.
Every now and then we're gonna get one of those mean ones, but I promise you, the whole test is not going to be that mean. Okay, you can go ahead and try, and if you want, because you know the website that Jonathan shared with you guys, okay, and you had this practice test. I think it cost like 14 or 20 bucks. You have it for some time. You have it for some time. You can go ahead and buy it, okay, but I don't know how long you have it because I don't want it to expire for you. Okay, you can try yourself. You can do the test and you see how the questions are, because they use the same, they have a large bank of questions and they keep, you know, like using from them. And then it gives you also, what I like about this test, that it gives you, it analyzes it. It gives you which area you need to work on. Okay. But it's going to take you like, it's timed also, I guess. But you still have, you will still have the test for some time.
I have a question. I'm trying to figure out from the question, where does it ask that it's divisible by 3? I don't know.
It doesn't. It doesn't.
Where are we getting that from?
Because it tells you it's a factor of 6. It tells you it's divisible by 6. So when it is divisible by 6, it implies right away that it's divisible by 2 and 3.
Okay.
Okay. So yeah, that's I give you that one already. And yes, they keep throwing one of those every now and then, but in the overall, okay, you're gonna beat that test. Okay, don't worry about it. And believe it or not, that was the first question on the practice test for me. When I did this one, I was like, oh my God, what am I going to teach now? It's a GMAT type of question.
Does this fall under number and operate? What does this fall under?
It's divisibility, so it is number and operation.
Oh, okay.
Okay. Now let's do another one that is easier, okay? And it's the type of, this is the type of question that you would expect, okay? The other one was really one of the mean ones. But this one is also easy because the options they gave you makes it easier for you.
I know you said this one is supposed to be easy.
Try them out.
I tried it out and I put my best answer in, but if you could go over this one too.
Yeah, well, I go over everyone. Don't worry
Thank
about it.
you.
We go over each and every question, even if you all got it right. Okay, unless that I got 100% participation on the poll, I might not go over it. But even so, I go over it because some of you might have been guessing. All right, so don't worry about it. All right, I'm gonna end the poll now, and your correct answer here is C. Okay, I'm sharing, and let's go. All right, so here we want the smallest possible multiple of 5. Okay, and definitely all the numbers have to be multiples of 5. Okay, so the first thing, it has to be multiple of 5. That leaves a remainder of 2 when divided by 6, and a remainder of 0 when divided by 4. Which means what? Which means it has to be a multiple of 5 and divisible by 4. And remember, the 4 is when you have the 2 last digits divisible by 4. So they're all 2 digits, okay? So simply, this number is going to be the only number that is divisible by 4, which is the 20, okay? But go ahead and check when you divide it by 6. 20 divided by 6 is going to give you, you're going 3 times 6 is 18, and then you have a remainder of 2, okay? So the options are easy for you to get in here, all right? So in here, we have, I'm going again, okay? You have 3 conditions. It has to be a multiple of 5, okay? So if I had here like 16, 16 would be wrong. And it has to leave a remainder of 2 when divided by 6, and they give you the hard condition at the beginning, but the easier one is the one remainder of 0 when divided by 4, which means it is divisible by 4. It's a number that is a multiple of 5 and divisible by 4. And then I can check for the hardest, for the harder one. Okay, I divide by 6 and see if I have a remainder by 2. So I'm looking at 5. It is a multiple of 5. It's not, it's just 5. 15, 20, 35. All right. So now, which one of those is divisible by 4? I mean, if I divide it by 4, I get a 0. 20 divided 4, I don't get a 0 when I divide it by 4. I'm sorry. I get a remainder of 0. Okay, when I divide by 4. So 20 divided by 4 is 5. Okay, and no remainder. 15, I divide by 4, I'm going to get a remainder of something. 35 as well. So it is the 20, okay? But I'm going to go and check, and I divide it by 6 and see. So 20 divided by 6, I get a 3. 3 times 6 is 18, and 18 is, 20 minus 18 is 2. All right? Okay. Now we're going to go into rounding numbers and estimating. And we do round all the time, okay? Rounding is different than estimating. Rounding, you have certain rules. But when you estimate, you do whatever, okay? But you're also rounding when you're doing this, but you're not following a certain rules. So let's go one by one, all right? So the first thing we need to know when we're rounding a number is, I'm going to go into the steps, all right? But then you will find out that you do it all the time without even noticing that you're rounding. Okay, so you round to which place? You underline the digit in this place. I'm going to get the example first. Okay, all right, so we're rounding that number. I can round that number to 10 numbers, or I can round it to whatever. I mean, you can round it to whatever. So first you need to know rounding to which place. You underline the digit in this place. Okay, so you look at the digit after, and then you see the digit after. I want to question. You were rounding to what? Here, to the nearest 100. So you go to the 100, to the 100 place, which is the 3. Okay, and you underline it. Okay, so that 3. So my friend, you just underline 3 because everything after 3 is going to turn to 0. Okay, but are you going to keep the 3 as is, or are you going to raise it? That is a question that is going to be answered when you look at the number following that 3, which is the 8. If it's 4 or less, you keep the underlined digit as is, okay? But if it's 5 or more, you add 1 to the 3, okay? So see, I'm going into steps, all right? But just look at the number. It's 389. Is it close to 300 or 400? Because this is what you're doing actually, right? Everything is going to be to 0. That number is going to be like this, okay? Okay, so you're looking at the 389 because you're looking at the 100 place. Is it close to 300 or 400? It is close to 400, okay? So that number, when you round it to the 100 place, will give you 400. All right, how do we do it using the rules? Okay, is that first, you need to look to see, to underline the number you're rounding to. It's the 300, okay? And then you look at the number after. If it's less than 4 or less, you keep the 3, okay? If it's 5 or more, you raise the score, so you add the 3. Now I want you, a lot of kids, when I was doing this in mid school or elementary school, they would go, and if it's less, they would do it a 2. No, you never cut the number down, okay? You keep it or you raise, okay? Because the 389 is between the 300 and 400. So I used to do another thing. I would say, like, okay, we're going to forget about the 56 because we're going to round the 389. 389 on the number line is in between 300 and between 400, right? And in the middle, I have 300. Oh my God, I did it wrong. Okay, I'll do it again. Sorry, just placed them wrong. So I'm in between 300 and 400, right? Because I'm doing 389. That is the number. The 56 is going to stay anyway. Nothing is going to change to the 56,000. In the middle is 350. Where is my 389? It's in here. So it's closer to the 400. So my number is going to be 56,400. Does it make sense?
Yes.
It does make sense when you think, yeah, well, but these are the rules. These are the steps. If you want to do by steps, okay. But if you want to make sense, I'd go for that. They will never ask you to round the question. A rounding question, you're going to estimate. That's the problem. We're going to look into this now. All right. So let's say here, for example, okay, we're going to do the same number, but this time we're going to round to the nearest 1,000. That would be my 6. Okay. So now I'm rounding the 6,000. Okay. I'm rounding the 6,000. This number here, 6,389. So I'm in between 6,000 or 7,000. The middle is 6,500, right? Where is my 6,389? It's in here. So I'm going to round down. When I say round down, it doesn't mean that I'm going to cut the 6. I'm going to keep it as is. But when I do this, it's going to be 6,000. So my number is going to be 56,000 ohms. Okay? But following the rules, let's follow the rules because they all give you the same thing anyway. You underline the number in the 1,000 place, which is the 6. And then you look at the number after. It's 3. Okay? It's less than it's here. It's 4 or less. So you're going to keep the 6 as is, and then everything is going to change to 0. Okay, 3 is less than 4. You keep underline digit as 3, and you replace the digit with zeros, and you got your 56,000. Okay, so there are 2 ways that you can go about it. Okay, just what makes sense. Just look at the number you're rounding. What do you want to do with it? This is the rule of rounding. All right, and we have this also. 5 or more, raise the score. You add 1. 4 or less, let it rest, or add 0. I mean, if you want to add something, you add a 0. Let it rest. You're not doing anything to it. But 5 or more, you raise the score. Anything below 5, you keep it as is. Okay, but then the rest of the number, the rest of the number turns to 0. All right. So you will never get a question like this in the test, because you can simply use this using a calculator. But let's do it together. I'm not going to give you I'm not going to waste your time with this. Okay, this is just an addition number. Okay, however, you don't even have to answer this question. Okay, you don't even have to do the math, because look at the answer they gave you. So at the grocery store, Susan purchased 4 items. She has 3.29, and then 0.79, 4.48, and 6.61. Which of the following is a reasonable estimate of the total cost of the item? You have the 3, and then you have $1, and then you have 4, and then you have 6. I mean, this one already, okay, they give you the 10. Okay, it's definitely going to be a 15, right? You don't even have to worry about it. You don't have to do the math. Okay, however, we're going to do the math, because, I mean, here I did that, just the rounding, but honestly, I'd rather that we use the time into something more efficient. But let's do the math here. Because I want to do that decimal part. When you're adding numbers with decimal, not that you're going to have to do this because you have a calculator, and your calculator is going to give you a decimal point. But I just want you to remember that when we add, we align our number to the point. Okay, we're going to discuss this also when we're doing the decimal, but that's it. Okay, so when you add, all your number has to be aligned at the decimal point. And it makes sense because this is all whole number and these are all less than 1. Okay, so remember, for example, if we were doing like 358 plus 49, you're going to align them all like this, right? You're going to do the long addition. Okay, but when you have decimal, that's not the way it goes. Okay, you align with the decimal point. All right, just a little bit to remember. Okay, now round the measurement of 28.57 centimeters to the nearest centimeter. Okay, to the nearest centimeter. Now I know that we here in the US, we don't use centimeter, we use inches and miles and yards and all those stuff. Okay, that makes it very difficult for us to do the math, but the rest of the world, my friends, uses the centimeter, which is a metric system, which is based on 100, makes all this calculation easier. Okay, we're going to get to this when we do the areas and things like this. All right, so here we're going to round to the 28. Okay, to the 8. So we're not going to have this. We're going to round to the nearest centimeter, which is 28 centimeter. This is millimeter. 28 centimeter, 0.57. Okay, decimal. What do you think? Is it going to be 28 or 29? What do you think? Okay, I'm going to put the point.
29.
29, right? Okay, you gave it away. Okay, no point. Easy. All right. Okay, so yeah, the rounding is going to, but the question are not going to be like this. The question are going to be to estimate, which we're going to do in a minute. Okay, what is a reasonable estimation for the following expression? Now I'm going to give you a poll, because now you're going to estimate, which you're going to be rounding as well. Okay, but it's up to you. What do you want to do? And be careful, my friends, when you're aggressive with your rounding, which means that you round down or you round high a lot, okay, you're not very conservative, your answer is going to change accordingly as well. Okay, so just be careful. All right. All right, I'm gonna end the poll now. Okay. And sharing the result. The answer is B. Yeah, most of you got it right. So I'm going to show you what I did, and you guys tell me what you did. So I went with the 51. I'm going to make it a 50. Okay, so here I rounded to the tens. Okay, and for the 743, I went ahead and rounded down for the 100. So it's 700. And I kept the 25 as is. I didn't change the 25. Okay, so now I have 50. And you be careful here because I went down dramatically. I went to 50. The 50 to 51 is not very dramatic, but 743 is kind of, all right. I mean, I could have made it 740. That would be more conservative. I would get an answer that is a bit closer, more closer to the right answer. But I was looking at this, the answer I have, and I found that they're not very close. Okay, 1,000, 1,200, 200, 2,000. That's okay. I mean, I can do that. All right. So I went with 51 to 50, 743 to 700, and I did my math. Okay. Now I don't have to do math actually because I'm simply going to simplify 50 by 25. I mean, I divide 50 by 25, I get a 2. 25 by 25, 1. So 2 times 700 is going to give me 1,400, which is at B. Okay. And I was okay with this. All right. What did you guys do? You want to share? The accurate solution
I'll
is
share.
actually
I did
okay. Go
the
ahead.
accurate
Yeah.
solution.
I just solved it and I got 15, 15.
Yeah.
Maybe it's an sorry, maybe it's an educated guess, but that's how I did it.
No, it's not. You solved you got the accurate answer. You solved it. All right.
Yeah, and then I got
Okay.
15,
It's not a guess
15.
at all. That's the right answer. It's
Yeah, and I knew
15,
it was
15.
between 1,200 and 2,000.
Yeah. You would I would probably do this if it was a test. I'm not gonna take chances. Okay, I'll definitely do this. Okay. Okay. But anyway, it just shows you when we're estimating, okay, it's up to you. But like I said, you're aggressive with your estimation, your number is going to deviate further from the number. So just take this into mind. Put this into mind when you're doing it. All right. All right. Now we're going to go into word problems. Okay. So most of the problems here, you got in the test. Okay. So I want to save time because it's 1:15 and I know you guys you took the test. So I'm not going to put the polls. I'm just going to go ahead and solve the one because I know that you already went through thinking about them when you did the test, so you can remember. All right. So this one says an airline has 3 flights each day from Columbus, Georgia to Detroit, Michigan. The early flight can carry 396 passengers on a jumbo jet, totally irrelevant information. The midday and late flight can carry 137 people on regular jet. How many passengers can be flown to Detroit on these flights? All right. So they told you 3 flights, okay? And they did not write number 3. Okay? They just used the letters to say 3. I'm just showing you how they're trying to confuse you in here. And they said the midday and late flight, and then you have 2 numbers, and you know that you're going to add. So you can go right ahead and add 396 and 137 and get an answer, which is going to be shown in here, but it's going to be the wrong answer. Okay? Because there are 3 flights, not 2. Okay? So that's why I really want everyone to read the question, the word problem, twice. All the problems, just read them twice. Okay? And write down in your in the scrap paper they give you. So you have 3 flights. Okay? If it was me, I'm gonna say this: 3 flights. Okay? The early flight takes 396. Okay? The midday and late flight, midday and 137. So it's 107, 137, and another 137. And then how many passengers can be flown to Detroit on these flights? I'm gonna make my addition, and it's gonna be 607. Okay, so if you got this one, these are the type of questions that you don't want to miss. Okay, so if you read it, you don't want to get confused. be careful, okay? Sometimes the questions are very easy, but they are worded in a way to confuse you a little bit. And let's be honest here, they want to make money out of these tests, right? Okay. Okay, you can also, all right, so you can also use an estimation. You can also, another option is to estimate. So over here, I have 396, which is 400, and then 140, 140. That's another way to estimate. Here I added 4, okay? And here I added 3, okay? But even when I estimate, I'm going to get 680, which is when I estimate 680. So it's between 70 and 60. Okay, what did I do? I added more, so it's definitely 670. You can think about it this way, but don't overthink it. Okay. However, that's another way to do your estimation. All right. So here I added 4, and here I added 3, and here I added 3. So in the total, I added 10. So when I do my math and I find my answer, I have to take away the extra number I added in my estimation. Okay. So I get the right answer here, 670. All right. Okay. But even if I don't do that part, if I'm going to go 400 and 140, 680, and I'm looking at the numbers, I have 670 and 660. I added, so I have to be the correct answer must be more than 670. So it's never going to be 660, so I can go with the B. Okay. Now, this one. This one, what does it say in here? It says the renting price of a boat is $120 per day for 6 adults for 1 day. So if you have a group of 6 and you want to rent that boat, all of you are going to pay $120. However, you're going to pay an extra charge of $15 for 1 child per day. So that's probably the rent of the life jacket that they have to put. Okay. And then a group, the question is, so that's the pricing. That's the thing that at the marina says this. And now we have a group of 6 adults and 3 children. They want to rent this boat for 5 days cruise. How much will it cost them? Now, so how much will it cost them for 1 day? That's going to be 120 because they're 6. Okay, and then 3 children, I'm going to add the 120 plus the 45, which is 3 times 15. Okay, so for 1 day, it's going to be 165. Now, I'm multiplying this by 5 because we're going to go for 5 days cruise. That's going to be 825. Okay. When if you're short on time, okay, you can see that 45 is almost 150. That's going to be like 200. Okay, maximum 200. 200 times 5 is going to be 1,000. Okay, so you're going to be between this one and between this one. Okay, but remember, it's 50 and 120. That's 175. So you will go with the down one, with the less one. Okay, if you do not have enough time, because sometimes you see that you spend so much time into your writing question, and then you need to do the rest of the questions. Okay, so you don't want to spend, you don't have enough, you don't have the luxury of solving it one by one. So I want you, when you're doing your questions, when you're practicing, to look at it this way. Do it first the fast way, okay, like you're stressed on time, and then do it properly and see if you got the right answer or not. Okay. Okay. All right. Now this one. This one, I'm pretty much sure that most of you got it wrong in the question and in the test. Okay, because it's kind of tricky. All right. So here we have 300 students in a certain high school. You have 200.
It wasn't on the test, Hoda.
It wasn't? Oh, that I'm gonna give a pause. Thank you. I'm gonna give a pause because I want you to try this one. This one was I'll give a pause for this one. Okay, go ahead. Ten more seconds, and then I'm going to. Oh, I'm still getting. All right. All right, I'm gonna end it. All right. I'm still getting answers. I'm sorry. Okay. Okay. I'm gonna end it now. All right. Sharing the result. The correct answer is 80. Okay. So 5 of you answered 80. So if you did it without guessing, do you want to share how?
I would like to
Lucy?
share if I can.
Yeah, sure. Go ahead.
Okay, so what I did was since there are 300 students in total, I circled the 300 students.
Perfect.
And then what I did was I wrote 200 football students and then 70 swimming students on the side. Since both together have 50 students, I added first 200 plus 70 and then subtracted the 50 students that are already counted in altogether with the signing football and the swimming. And then he gave me a total of 220. From the 220, I subtracted the total amount of students that I circled first, that were 300 students. And he gave me an answer of 80.
That's perfect. That's perfect. That's exactly it. All right. Because you have 200 they signed for football and 70 signed for swimming. And 50 signed up for both football and swimming. So those 50 are counted twice. Once here and once here. All right. So I did the same thing, okay, if this is what you meant. So I have here high school is total 300, football is 200, and then the swimming is 70, and there is 50 in the middle, okay? So now I can go right away. I found that whoever is playing only football is 150, and whoever is playing only swimming is 70 minus 50, which is 20. So now I have 20 doing swimming and 150 doing football only and 50 doing both. So I'm going to add them. 50 plus 150 is 220. Out of the 300, 80 students did not do anything. Okay? So here
I'm
you go.
confused.
Okay, let me do it again.
I got half of the answer. So I did 300 minus 200 is 100. And then I did 100 minus 70 is 30.
Okay, so what did you do with the 50 that signed up for both?
I didn't do anything with that one.
Okay. Okay, so cool. All right. So you have 300 and you took away 270. Okay. But then there is 50 who signed up for both, which means they are already, you added them twice. So you should have subtracted the 50 from the 270 that you get. Okay. because you added them twice. Let me do the Venn diagram twice. Another one, another way.
Okay.
So here we have 300, all right? Agree? And then we have 200
Yeah.
for football. And then we have 70 for swimming, correct? And then you have 50 doing both. So you see it now? I'm not going to do anything. Do you see it now?
Yes.
Okay, so the 50 are counted twice. Once for the swimming and another time for the football. So you need to fix your numbers a little bit. Okay? So those who did only football are 200 minus 50. I mean, I recategorized the problem. I have only football, that's 150. Okay? Only swimming, that is 20. Both football and swimming is 50. Okay? So these are the kids who played sport. The 20 are swimming only. 50, they're doing both. These are the active ones. And then 150 are doing football only. Okay, I add them, and then I got 220. You take that from the 300, and you got your 80 student who decided the rest this semester. All right?
Yes, thanks.
Let's do it mathematically. Okay? So total number of students is 300, football 200, swimming 70, football and swimming 50. Only football, 200 minus 50, 150. Only swimming, 70 minus 50, 20. Football and swimming, 50. Number of students signed for sports in general is the 150 football player, the 20 both sports, the 50 only swimming, 220. 300 minus 220 is 80. Okay? So the 50 that signed for football is the trick in here. Okay. This one was on the test?
Yes.
All right. So you have 2 math class with a total of 329 students. However, the 10 a.m. class has 53 more students than the 8 a.m. class. How many students are in the 8 a.m. class? Okay. I would draw. I definitely go for drawing. Okay. So I would say, okay, that without the 53 students, I have equal classes, right? Correct?
Yes.
I mean, if
Yeah.
I have here, I have 329 students. One class is the 10 a.m. This is the larger class, okay? And the 8 a.m. is not the so large class, okay? The less class. 53 or more. So I'll take out the 53. And then I'm going to have 2 equal classes. So if I go 329, I'm going to do the math with you now, but I just don't remember it, okay? Now I'm going to have 2 equal class. Whatever I get here, whatever the difference is, I'm going to split by 2, and these are my 2 classes. So now I know everyone in the classroom, the number of students in the classroom, all right? Let me go ahead and show you the neat way. So 800 is in the X, is X. I mean, what did I say? 800. X student is in 8th class. I don't know the X, but the 10 has X plus the 53. Okay. Now I'll take, that's algebraically okay. Take the 53 out of the 200. Let me see if I have the other version here. Yeah. Take the 53 out of the 329 and you have a 276. Okay. Now, the 276, if you split them into 2, you have 138 in the 8 a.m. class and 138 on the 10 a.m. class, but then add the 53 so you have it. What do they want? They want how many students are in the 8 a.m. class, which is the 138. Got it? Okay.
Could you go back to the last slide?
The one with the algebra?
Yes.
Okay.
And could you draw it?
It's right here. Okay. So the 8 is that number. Let's say it's X. And the 10 is X plus 53. So now what I'm going to do is that I'm going to do 329 minus 53.
Yes.
My answer is what? Get the answer. Let's not do the math here with you guys because we want to save time. The answer is 276. Correct?
Yes.
So now 276 is split into 2. If you do 276 divided by 2, okay, your answer is going to be 138. So I have here 138 and here 138.
Got it.
Okay.
Wow, thank you. So easy how you explain it. Thank you.
You're welcome. Okay. All right. Okay. This one, I'm pretty much sure everybody got this one right because it's paycheck. Okay. We all know how to calculate our paycheck. Correct?
It's money.
Yeah.
Money.
All right. Whenever the question is about money, you know, like your mind is wired to work properly. Okay. So when we go into the discount and the percentage and things like this, you're gonna see how easy it is. All right. So we have here a worker that is paid $12 per hour for the first 40 hours she works. Then she's paid an additional $2 per hour beyond her base hourly rate for each hour over 50 that she works. How much will she earn if she works 52 hours? So if she works within 40 hours, she gets 12. Any hour over, she gets 14. Okay? So as simple as, okay, she works 52 hours. That is 40 plus 12. The first 40, she's earning 480. 40 times 12. The next 12 times 14 is 168. You add them together and you get to 648. All right? Questions?
No.
All right. Let's go. Now, this one, did you get that one on the test?
No, this one was not it.
All right. But also you this is also a shopping, so you be able to do it right. I'm going to give you a point for this one. Okay, here you go. I mean, nowadays, when you go to Costco and you go to the stores, they always tell you the price for the units. Okay. All right, I'm gonna end the poll in 10. I'll give you another 10 because I'm still getting answers. All right, ending it. And you sharing, most of you got it right. It is the A. Okay, let's do it together. So we have an 8-ounce can of juice that costs 50 cents. And then we have a 16-ounce that costs 90 cents. How much money can be saved by purchasing 320 of the larger size? So we made the decision. We're going to buy the 320, the larger size, the 16 ounces. Okay. So let's see how much we're going to pay for the, because what we want to buy 320. So how many can do I need? Okay. If I'm going to buy the 8-ounce And how many can do I need if I'm going to buy the 16 ounce? The price for that and the price for that, I subtract, okay? So the 8 ounce is for 50, okay? And the 16 ounces for 90, that's what I have, okay? Now, I'm going to divide 320 by 8, okay? Because I need 320 ounce and I have 8. So 320 divided by 8 is 40, okay? And I'm going to get 40 cans of the 8 ounces that are for 50 cents. And I'm going to get 16 because here I'm dividing 320 by 16. I'm going to need 20. Now the prices. 40 times 50 is 2,000 cents, which is $20. And 90 times 90, 20 times 90 is $18. So I saved $2 using the larger can. All right. I think I'm gonna stop in here, my friends, because we're almost through. We have 20 minutes, and I feel that you're overworked, a lot of work. So next time we're going to take it from here. Okay, we're not gonna forget about this part. We're gonna take it next time. We're just gonna stop the recording here. Okay.